Hi Chemistry. It is September 30th on a Wednesday. I'm going to take you through what we practiced in class today. We practiced using chemical formulas with a mercury 1 ion. So if you have your study guides handy, you can pull that up. You can also pull it up, from Canvas. I'm going to just pull mine up on Canvas really quick. It is in your new module called Names and Formulas, and it's called Green Sheet Study Guide. So what we've done on this green sheet on this study guide is today we are focusing on mercury 1. You'll see mercury 1 right there. It's an Hg2 with a 2+ charge. We just need to know its stock name. The classical names you do not need to memorize at all. Those are just for your own knowledge. If you had some older chemicals and you had they were labeled in this way with a mercuric or mercurous, then you would know if it was a mercury 1 or a mercury 2. But you don't need to know these classical names. Okay? So I'm going to take you to my board here, and we're going to look at mercury 1. And the really interesting thing about mercury 1 is it's, first of all, it has a charge of 2+, which doesn't really go along with the naming system that we've had in place. So mercury 1 still gets a 2+ charge. We have to keep that in mind. The other thing is, you'll notice that 2 that is subscripted. It means it's diatomic. It means there are 2 mercury atoms that are functioning as a single unit. So I tell kids in class to think of mercury 1 as kind of having a Siamese twin. If you had a Siamese twin and you were attached at, say, the brain and you couldn't be separated, right? Everywhere you went, you would function basically as one single being. That's how mercury 1 in its diatomic state functions. So today we learned that we can still create any kind of ionic compound using something such as mercury 1. And we will still use the crisscross method, which I've outlined for you in blue up there. But in the case of mercury 1, you'll notice right here, we need to have 3 of the mercury 1s to balance out. So anytime that we are going to need more than one of a special unit that is diatomic, we will wrap it in parentheses. And then the 3 right there, you will see, goes on the outside of the parentheses. You don't need that little blue line I've drawn. I just drew the blue line to show that that 3, it's a multiplier. And it does only go directly to the Hg, to the mercury 1. Okay, so we are going to have a mercury 1 nitride is what we formed. We still used our crisscross method. But because I needed more than one of those mercury 1 entities, I have to wrap it in parentheses. We can do the same thing with something such as a mercury 1 carbide. We're still going to write out its ionic charges. It still has a +2 charge for the mercury 1. Carbide has a 4- charge. So we are going to crisscross their charges. Okay? Originally, when we would crisscross this, let me back up. We would bring the 4 down to follow the mercury 1, and we would bring the 2 from the mercury 1 down to follow the carbide. But we're going to still follow our rules that say reduce to the lowest whole number ratio. So what we're going to do in this case where I have a 4 to a 2, I'm going to divide each one of these by 2. My 4 becomes a 2, my 2 becomes a 1. And my final formula for mercury 1 carbide would read Hg2 in parentheses 2 and the C. Okay? If I wanted to make something like a mercury 1 oxide, we could do a mercury 1 oxide as well. We're going to write out its charges with the superscript. And we're going to write out oxide's charge with the superscript. Oxide is a 2-. We can still follow all of our ionic compound rules that state if we have a +2 combined with a -2, we can already just squeeze their symbols together. They already add up to a net zero ionic charge. So in this case, for a mercury 1 oxide, I can just have the final formula be Hg2O. That's my final formula. Okay? So we learned about that in class today. How to use our parentheses when needed. Anytime we need more than one of any entity that has more than one atom involved, we will use parentheses. So the next thing we learned about was we looked at the very top of this study guide. Okay, we looked at the -1 column, the -2 column, the -3 column, and the +1 charge of these common polyatomic ions, which you find at the top of your study guide. Each of these things has a overall net ionic charge. In the -1 column, everything in this column has a charge of -1. Everything in the -2 column has a charge of -2. Everything in the -3, the phosphate, overall have a -3 charge. And we have one special one that is a loser of electrons, the ammonium, which is the +1. These are going to function much like the mercury 1 did. We can put any positive, such as an ammonium. An ammonium can go with any of these negatively charged entities over here. They are all comprised of multiple atoms, but they all function as a single entity. Okay, so the ammonium can go with any of these negatively charged beings, as well as any of these 3 negatively charged ones. They can go with anything with a positive charge. So they can combine with any of our 8 metals found down here that have more than one ionic charge. And they also can go with any of our elements that are on the left side of that stair-step line. Any positive half can go with any negative half. The positive half must come first. So we're going to practice writing a couple ammonium compounds because it's going to help us with writing our parentheses. Sorry, I'm trying to write and talk to you at the same time. So I'm going to make an ammonium nitrate first. Nitrate is found in the -1 column of the study guide. So I'm going to just write up here. I'm going to write my ammonium half, NH4 with a +1 charge, and my nitrate is an NO3 with a -1 charge. To make an ammonium nitrate, I still follow the same crisscross rules. And my crisscross rules say make ammoniums superscript, become nitrates subscript, make nitrates superscript, which is the negative, become ammoniums subscript. And my rules say if I already have a +1 combined with a -1, I can just do what I like to call the squeeze, where I squeeze their symbols together. Okay? So my final formula for ammonium nitrate is there in the box. I did the squeeze. I squeezed it together. No parentheses are needed because I do not need more than one of either group. Now let's do one where I will need more than one. Okay? We're going to do an ammonium with a sulfate, which is in the -2 column. Sulfate reads SO4 with a 2- charge. Okay? If I want to put the ammonium with the sulfate, I am still going to crisscross the charges. Being that I'm going to need more than one ammonium group, I'm going to lock it in the parentheses, and my 2 is going to go on the outside of the parentheses. The 2 came from the sulfate. Now, ammonium has a charge of 1, which means I will only need one sulfate group. So here is my finished formula for an ammonium sulfate. Okay, I have crisscrossed the 2. Let me get my marker on the screen. The 2 came from the sulfate up there, crisscrossed. The one from the ammonium follows the sulfate. We have to keep this whole sulfate group together, the SO4 group, okay? If I wanted to put ammonium with something else, let's put it with a phosphate, okay? Phosphate is in the 3- column. It is a PO4 group with an overall 3- charge. That's how I would write its half. When I go to put ammonium with the phosphate, again, I'm going to crisscross. The 3 from the phosphate needs to come down and follow the ammonium. Now, ammonium's 1 follows the phosphate. So I don't need to do anything to the phosphate group but make it follow the ammonium. This would be an ammonium phosphate. Okay? So we're creating ionic compounds using polyatomic ions, ions made of many atoms that function as a group as a whole. Okay? I can make things with a phosphate group. I can make something, say, instead of an ammonium, I can take something like a copper 2. So let's do a copper 2 phosphate. If I wanted to make a copper 2 phosphate, I've written their ionic charges. I'm going to crisscross. I'm going to take the 2 from the copper and make it follow the phosphate. I will take the 3 from the phosphate and make it follow the copper. So when I write its formula, copper gets the 3 from the phosphate. Because the phosphate, I'm going to need more than one of them, I will lock it in the parentheses and I make copper's 2 follow the parentheses. This is the correct formula for copper 2 phosphate. I'll just put a little box around it to make it look fancier. Okay? So, we got some practice using polyatomic ions. We're using them with regular elements. We're also using them together with a positive half first and a negative half second. That's what we practiced in class today. There is a homework assignment listed in Canvas. We did not actually get to it today in class, so I'm not going to talk about it on the video today. I will make you a video tomorrow. I hope that that's okay. So this will give you the basic idea of how to do that. All right? I will check in with you all tomorrow. Bye.